Hello, welcome. Now we're gonna talk about computer network basics. Today we're covering the absolute essentials of computer networking. We're going to build this story from the ground up. First, the big picture: LANs, WANs, data center, and how the global internet is physically connected. Then we'll zoom into the two most important conceptual models: the 7 layers OSI model and the 4-layer TCP IP model. These are the lenses you will use to understand how to troubleshoot every network problem you ever face. Now let's jump in. Now we're gonna talk about LAN versus WAN. Where the network begins and where it ends. A LAN, a local area network, is your home Wi-Fi or office network. A small area, your own hardware, high speed, low latency, all your devices connected to a switch and a router. Often in the same box, they share the same addresses, space, and can talk directly to each other. A WAN is a wide area network, connects LANs across cities, countries, and continents. The internet itself is the ultimate WAN. The hardware belongs to ISPs and telecom companies. The travels across fiber optic cables. Latencies is higher because of the sheer physical distance. But here's what it matters. The same protocols works on both. Whether you are printing to a local network printer or loading a website hosted halfway across around the world, your data is packaged the same way as LAN and WAN are, just about the scales. Now we're talking about data centers. Data centers, the physical heart of the digital world. The cloud data centers are the same. The cloud is not fully white thing in the sky. Data centers are massive. They are a secure warehouse filled with thousands of servers stacked in racks with redundant power cooling and internet connection. When you upload a photo, stream a video, or send an email, your data ends up on a hard drive spinning inside one of this building, and that is called a data center. Inside of data center, you have got a lot of enormous scales. There are LANs, servers connected by switches, all talking incredibly fast. Data centers don't just ignore files; they run application, process searches, host databases. When you hit enter in Google, hundreds of servers work together and send back result in a milliseconds. The key point is that every digital services you use lives somewhere in the physical. The cloud is just someone else's data center. And now we're talking about the global network, connecting the data centers across the planet. So how do you reach a data center to another continent? That is called fiber optic cables. Massive bundles of glass thinner than a hairy human hair carry pulses of lights. These cables run long railways around highways across ocean floors. This is the physical backbone of the internet. Here's the journey. Your request leaves your LAN and hits your ISP, travels across regional fiber, enters a long-haul backbone, possibly crosses undersea cables, and arrives at distant data center. The response makes the same trip back, all under in 100 milliseconds. Along the way, DNS servers translate the domain name and you type into the IP address. BGP, the border gate protocols, find the best path across this interconnected network. Tier 1 providers like AT&T and NTT own the backbone cables and pair with each other internet exchange points around the world. That is the physical infrastructure. Now let's look about the conceptual framework that explains how data actually moves through all of this. Now we're gonna talk about the OSI model. Say a 7-layer framework for understanding the networks. This is the OSI model. Open system interconnection, 7 layers. From the physical cable to the application you interact with. No one built network exactly to the OSI specs anymore, but every network conversation uses its layers. You'll hear that it's layer 3 issues constantly. Let's walk top to bottom. Now we're talking about layer 7 application. We're starting at the bottom. These are the protocols your software speaks. It's the HTTP for web, SMTP for email, FTP for file transfer. This is where the data originates. Now we're talking about the layer 6, pretensation. That's translation, encryption like TLS lives here, data formatting, character encoding, ensure that the receiving side connects and can interpret what was said. Now we're talking about layer 5, session. This manages conversation, setups, maintenance, teardown, take off a Zoom call on login session. Now we're talking about layer 4, transport. This reliability layer, TCP guarantees delivery with acknowledgements and puts every backbone in order. UDP is faster but doesn't guarantee anything. Do it for live streaming and gaming. This layer adds ports numbers so receiving computers knows which application gets the data, and this layer data is called segment. Now layer 3. This is where network engineers focus and fix troubleshooting a lot. The home of the IP address routers lives here. We read the destination IP and forward packets hop by hop across networks. This is the layer that makes the internet possible, connecting different together. And this is where data is called packet. Now, we're also going to talk about layer 2, and this is where also network engineer troubleshoot a lot. Data link, MAC addresses, which for writing frames based on MAC addresses within the local network. Error detection happens here, and this is where it calls frames. And layer 1, the physical, the actual hardware cables, fiber radios, waves, where raw bits converted into signals, no intelligence, just transmission. 7 layers, physical, data links, network, transfer, session, presentation, and application, bottom to top, and that's how data flows. Now that we talk about the OSI model, we're going to talk about the TCP IP model, the 4-layer protocol that runs the internet. The TCP IP model is what internet actually runs on. This is the modern OSI. It is the development for ARPANET, the procedure to the modern internet. 4 layers instead of 7, they map the cleanly to OSI. The application layer combines OSI layer 5 and 6 and 7, session, presentation, and application. Become one. HTTP, DNS, SMT, they all live here. From the network perspective, everything about transportation is just application data. Basically, they shorten it. The transport layer maps directly on OSI layer 4. TCP and UDP port numbers, same function, instead separate because end-to-end reliability is critical to merge. The internet layers maps to OSI layer 3, the IP addressing and routing. This is where packet cross network boundaries. The network access layer combines OSI layers 1 and 2, physical and data linked together, Wi-Fi, MAC address cables, all of it. Now that the most important concept, encapsulation, on the sending side, each layer wraps the data with its own header. Application data gets a TCP header, then an IP header, then frame header, then it's transmitted as a bits on the receiving end. Each layer strips its header, passes the data up. The application gets exactly what was said, completely unaware of the incredible journey across lands, through data centers, and over the global network. Now to wrap it up, so the LANs to WANs, data centers to global fiber, 7 OSI layers, the 4 TCP IP layers. Take it as in layers, troubleshoot layers, it's capable. Is it a cable problem? Layer 1 IP routing, layer 3 a closed port, and layer 4 the mental model solves problem fast. Thanks for watching. Drop a question if you have a comment, and I'll see you in the next one.